I really did though. So I want to go over a handful of questions from the homework. As you're getting stuff out, I just want to kind of talk about a change that I'm going to make in regards to homework. Instead of making homework due, I want to make homework due at 11:59 p.m. the day of class. So and this will start tonight. I'm going to give you homework tonight over 1.6. It will be due tomorrow at 11:59 p.m. Okay? I think that allows you to work on it tonight, get hopefully all of it done, or most of them, at least expose yourself to a majority of it. And then if you have questions in class tomorrow, we can ask those questions before it gets graded on. Does that make sense? And you can finalize things tomorrow after school then before it gets graded. Now, that being said, tomorrow I will also give you homework over 1.7, which will be to do the next day, 11:09 p.m. Well, if you wait to do tonight's homework tomorrow after school, then you got either 2 assignments tomorrow. Tomorrow's back, and now we're back on the same idea, same schedule. We're not having time in class to ask questions. You have to look at things, right? So what I want you to still approach it like it's due during class, but know that you can still ask questions and still reap in the benefits of the answers to those questions. I like that idea if we approach it right, the way that I've intended us to approach it, and we'll just test the waters and see how that goes. Maybe it's something we keep, maybe it's something we amend and change, and but right now that's kind of what I'm going to do. Yeah. Yeah. All right, so doing this one, order of operations. Tells us that we need to view, remember what the division bar symbolizes? Okay, the division bar symbolizes and says your numerator is ultimately inside its own set of parentheses. The denominator is inside its own set of parentheses. So what we want to do then is kind of treat it like it's 2 separate problems until the very end. So I'm going to take that pink phrase, going through the order of operations, and I'm going to pay attention to parentheses. Are there any parentheses up here that I can do work inside of? No. Okay. So I can't do parentheses. Are there any exponents in the pink? Nope. Any multiplication? Yes. So do that multiplication. I'm going to do that multiplication right there. And what's 5 times -2? -10. Okay. Now, I'm going to write this. I'm just going to be deliberate with it. Okay. But now, as I go through order of operations again, what's the next thing to do? Do I do this subtraction here, or do I do this multiplication? I do that multiplication. So what's a -4? Remember, we always got to use the sign out in front. What's a -4 times a -4? Positive 16. So we got -10 plus 16. Some of you might jump straight from
you might jump straight from like this step here, and you might do that multiplication at the same time that you do the 5 times negative 2. So you might say negative 10 plus 16 right away. Is that okay? And that's fine if you do that. That means you've got a pretty good understanding of what your order of operations are telling you you're allowed to do. But now you would rewrite that as what? 6. Okay? So now so that's with the top. We now know the top evaluates out to give me 6. What's the bottom? If I look at that, the order of operations down there is a little bit simpler. What's that going to turn into? Negative 3, right? So what's 6 divided by negative 3? Negative 2. Okay? Now, I told the last class this, and I'm going to show you guys as well. If I open up Desmos, and I type this thing in, okay, 5 times negative 2 minus 4 times negative 4 divided by 3 minus 6. The nice thing about Desmos is that I can type it in, okay, and this is the exact same calculator that you're going to see on the end of course exam, but I can type it in, and it's going to write it the way it looks written on my paper, right? Not all calculators are that way. Most of your calculators are not that way. So that's convenient. That's nice. Okay? It tells me exactly that I've typed things in correctly. It's going to do the order of operations the way I would do it by hand. And it gives me negative 2, right? So that validates my answer. Here's my philosophy on this. If you grab your calculator at the onset, just to let your calculator do anything, you're not learning anything. You're not showing me that you know anything. You're just able to push buttons. Okay? I'm going to take your calculators away from you at some point. Many times throughout the year, it'll say, hey, this quiz, no calculator. This quiz, calculator. This quiz, no calculator. This test, no calculator. Okay? But I want you to gain an understanding for the order of operations so that later on, you know what we're doing with more complex ideas. If you don't understand the order of operations because you always use your calculator to do them for you, that's going to mess up your entire high school career in mathematics. Okay? Now, I'm not saying don't use your calculator. I'm saying do everything by hand like we did, and then get negative 2, and then grab your calculator and see if you still get negative 2. Does that make sense? Use your calculator as a tool to check your answers, not as a tool to provide you your first initial answer. All right? If you approach things that way, you're going to gain a lot more knowledge. Math is going to be a lot simpler to you later on. Okay? My thought is, think about this, if you're a person, I say this to everybody, every class I have, if you're an individual that thinks that mathematics comes difficult to you, okay, then you cannot approach math the same way that you've been approaching it for 10 years. You got to do something different, right? Okay, if something is difficult, if it's hard, and I've been doing it over and over and over again, and it's still difficult or still hard, maybe the way I've been doing it, I've got to rethink that process. Okay, so if I've always been using my calculator and things are hard because I don't really know what my calculator is, I need to adjust and not use my calculator, okay, and actually learn the math. So hopefully that is something we can think about. This one here, they ask us to evaluate negative C, or the opposite C, plus B minus A. All right, but they give us values for C, B, and A, right? So all we got to do is substitute. When we substitute here, okay, so C is equal to 3, right? And when I put in the opposite of C, what am I going to put there? Negative 3. So negative 3 then plus B, but B is negative 4.2. So whenever I substitute, and it's a good practice for you to develop, okay? Whenever we substitute values, keep parentheses around them. Okay, especially if they're negative. Now, I know I didn't do that with the negative, but if I'm going to substitute a negative value in for B, I'm going to put parentheses around that. Okay, and I'll talk about that, why I do that here in a moment. And then minus A, what am I substituting A in with? Negative 5. Okay, I think if you don't do that, you would have negative 3 plus minus 4.2 minus 5. And if I say things like that, if I say plus minus or minus minus, That gets confusing to people. But if I say I'm adding negative 4.2, or the opposite of 4.2, and I'm subtracting negative 5, with the parentheses, that's a little bit, I think, more apparent to what we're doing, okay? Another reason for that is because now, if I'm adding the opposite of something, so I highlight those two symbols. What do we say adding the opposite was equivalent to yesterday? Subtraction, good. Adding the opposite turns into just subtraction. So, when I see a plus followed by a minus, you're adding the opposite of something, so might as well just turn it into that definition of subtraction. Okay? Now, if I subtract the opposite of something, subtract the opposite, what's that the same as? That's the same as adding, good. Okay? So when I see a negative followed by a negative, I'm going to change that to a plus, and now I've got that. Now that makes it a little bit simpler, right? Okay? Now I had an issue in the last class. Somebody asked, how come you're going to do this addition first? And I call it addition, but it's effectively subtraction. I'm going to do that first. And they said, well, adding comes first. So I need to do negative 4.2 plus 5. And that's fine. You can. Okay? But doesn't PEMDAS say that we need to work left to right and add and subtract based on seeing it left to right? Now, because it's all addition or subtraction, I can actually group the negative 4.2 and the 5, add those together first, and then subtract 3. Associate property, community property, all that kind of stuff exists here. But what a lot of people will end up doing is that they will say that the 4.2 plus the 5, it should be negative 4.2 plus 5. They will rewrite it and make it a 9.2. Does that make sense? Where it should actually only be 0.8 if we add those two things together. I think it's safer, probably most of the time, to work left to right. Do that first. Negative 3 minus 4.2. Good. Negative 7.2. And then I didn't do anything with the plus 5, so I'm going to leave that alone. So now I've got that negative 7.2, add 5 to that, and I'm at negative 2.2. Good. Does that kind of make sense? Okay, now like I said, you could have been a person that says, I'm going to take negative 3 minus 4.2 plus 5, and I'm going to group the first two. I'm going to group that one and that one. So that gives me negative 3. Okay, now I add those two together. Okay, that should give me 0.8. And now negative 3 plus 0.8 still gives me negative 2.2. So the associate property or the commutative property, whichever one you want to use to group the 5 together, will still yield negative 2.2 for us. Is that all right? Okay. This one, we've seen this one several times in a couple assignments, but we still get 4 or 5 people on each assignment to miss it, so I want to make sure we talk about this one. Again, order of operations. If I look at this, so the order of operations says, look at your parentheses. This thing bugs me. It won't let me select my highlighter. There we go. So order of operations says, look at your parentheses, right? We're going to look at those parentheses. Okay, and just focus on the yellow stuff. So basically it gets me to ignore the 3 up front, right? And then I'm going to run through the order of operations inside the yellow. Well, I got to regenerate this order of operations, so I start back at P, and I got to go through everything that's in yellow and see if there's any parentheses inside the stuff that's yellow. So there are inner parentheses inside the yellow, right? So I work in them. Okay, that's what I focus on. And then in the green stuff, I'm going to run through the order of operations again, starting at P. Are there any parentheses inside the green yet? Nope. Okay. So I go to the next one. Is there any exponents? Nope. Any multiplication? Nope. Any division? Any adding? Any subtracting? So I do that. Okay. So I'm going to get, everything else stays the same. I have still a 3. My pen. All right, so I've got my 3. I've got my 6. Plus then 6. Now this goes to 3, right? Okay, you can write that 2 ways. You can write it this way. But if you're a person that says, I don't like to deal with that because it brings in parentheses that get me confused with order of operations, does that go down to just this? Does it mean the same thing? Okay. So now I've got basically a new expression to work here. I still got parentheses, so I'm going to run through the order of operations there. What do the order of operations tell me to do there? PEMDAS, go through the green in PEMDAS. Are there parentheses inside there? Inside the green, are there more parentheses? No. No. Is there multiplication? So you got to do that first, right? And now, something to think about when we multiply, when we do any of these operations, and this is according to order of operations. Whenever I find a symbol as a plus sign, a multiplication, a division, or a subtraction, I only do that with the things that are directly to the left and right of that symbol. So I look at that dot up there. What's the thing directly to the left of the dot? 6. What's the thing directly to the right? 3. So those are the only things I do that operation with, right? Okay. I'm getting people to want to say, oh, the thing to the left of this dot is 12. Well, that violates the order of operations because then you're doing addition before you're doing that line there before you do that line there. Okay. So make sure we write this as 6 plus 18. Now, what can I do now inside those parentheses? You can add those, right? I get something looks like that, which is the same as that. What's 3 times 24? 72. We could continue, guys, and I know sometimes it might feel like I get this, I understand what's going on. We're beating a dead horse, okay? But you're going to find out how important order of operations, how important commutative property, associative property is through the algebra that we're going to do that's going to be new to you, okay? Early on, some of this algebra is not new to you, okay? Eventually, it will be entirely new to you. It'll be the entire chapter will be completely new to you, something you've never seen, but it will incorporate order of operations, associative properties, commutative properties. We have to have a good foundation of those things. Okay. This one, you're just kind of looking at it to begin with, it looks kind of messy, but if we focus on like that being a square bracket, I'm going to go find the square bracket that closes that. So it'll be the next bracket that faces the other direction, right? So I keep going through. There's the first bracket that faces the other direction. Okay, then I get the plus sign. And then I get to this bracket. And I'm going to follow that through until I find the next bracket in the other direction. And we'll do the same thing then. Orange. Huh? There's a rainbow one? I wasn't paying attention. Yep. That one? Alright, so the first red grouping, guys, is that like a question that would have been like question 1 or 2 or 3 in the homework assignment? Yeah, it's very simple, right? Basically what this is, it's an elongated problem, but it's It's the collection of 3 individual simpler problems. And if we can break this harder problem down into smaller, easier problems, it shouldn't be too big of an issue, okay, to solve it. So what we want to do is look at this first set of parentheses. So I got a -5 plus a minus, or -6. Doesn't that turn into -5 minus 6? So what's -5 minus 6? -11. -3. It's plus a opposite of 6, so adding the opposite is the same as subtraction, right? So -3 minus 6 gives me -9. And again here, 11 plus the opposite of 9 is 11 minus 9. And that gives me 2. So that's finding those individual parts, right? Now that plus sign should stick those 2 together, right? This plus sign should stick those 2 together. Let's group those 2, left to right. I've got -11 plus the opposite of 9. Well, plus the opposite turns into minus, right? And I've got my plus 2, so I'll just write plus 2 here. If I group those 2, what's -11 minus 9? -20. Then plus 2 will give me -18. Okay? I think it's important, guys, and I know maybe some of you are saying I can do all that in my head. Okay? I'm going to do many parts of that in my head. I don't need to write all that stuff down. I'm going to write that stuff down, okay? Because, one, I'm trying to capture it in a recording so that you get home and you get stuck on something, you can go back and say, okay, what was the logic of what we did here, okay? Or if you need extra examples to get yourself unstuck, you can use this with other examples to get yourself unstuck and all the steps that are incorporated, okay? If I were to give you a math textbook, a lot of times the examples they give, they take liberties in assuming that you know maybe 2 or 3 steps, and they do them all together at once. And then people get lost. Okay, so I want to make sure that everything is structured and deliberate so nobody gets lost. I think that's the last one I had. Now, Travis, you said you had a question about one? 7? Let's see if I can. I don't have it open. While that opens, I'm going to give you guys today's notes, which are not going to be difficult to discuss. Huh? I doubt what time she's here. You can go to the office though and tell them. So mean. Okay, so if we're going to run through that, there's parentheses that I can do some work with, right? These parentheses, there's some operations there. So -2, that's going to turn into what? 1, then plus, and now -9 times 2 squared, okay? So we've done parentheses. There are still parentheses left over, but they just mean multiplication with the other parts, right? So there's nothing I can do inside them. So then I get to exponents. Is there anything with exponents in here? That's my exponent, right? That exponent gets applied to only the thing it's directly behind. And these parentheses are telling me the object that the 2 is directly behind, or the power of 2 is directly behind, is the base of 2. So what it's saying is that you're going to take the base of 2 and multiply it by itself twice, and what should that green stuff then turn into? 4. So I now have negative 2 times 1 plus then negative 9 times. Done with exponents. Now I got to go multiply, divide, left to right. So what's that one going to give me? Negative 2. What's that one going to give me? Negative 36. Good. And they're stuck together with addition, right? Well, I've got negative 2 plus the opposite, so that turns into subtraction. What's negative 2 minus 36? Negative 38. A lot of times, a lot of times when we're struggling on these, and I'll give you your worksheets back hopefully tomorrow, I'm looking at those, we go from like one line, like we'll have this, correct, and you'll show me that, but then you jump straight to the answer, and maybe you have an answer of like negative 40, where your math doesn't support negative 40, you've done some step in between, maybe on a calculator in your head or something like that, and I can't see